Everyone says quantum physics is mysterious, strange, impossible to understand, counterintuitive. They're right. But here's the thing. Nobody really understands quantum mechanics. Not the way they'd like to. But I can tell you how it works. That's actually very simple. Let me show you. In everyday life, everything makes sense. You throw a rock, it follows a path. A ball rolls off a table, falls to the ground. A car turns right, it doesn't go left. Objects exist in definite places. They move at definite speeds. A thing is either here or there, not both. That's common sense. And in the world of atoms, it's completely wrong. At small scales, things don't work this way at all. Electrons, photons, atoms, they don't behave like anything you know. Newton thought light was made of particles. Then we discovered it behaves like a wave. Then we found that light sometimes behaves like a particle after all. Same story for electrons. First particle, then wave behavior. So we gave up. It's like neither. To understand this, imagine 3 experiments. First, bullets. A machine gun sprays bullets through 2 holes in a wall. A detector behind measures where they land. Close hole 2, you get a pattern. Close hole 1, another pattern. Open both, the 2 patterns add up. Classical physics. Second, water waves. Waves go through 2 holes. They meet on the other side. Peak meets peak, they reinforce. Peak meets trough, they cancel. Result, stripes. Bright, dark, interference. Third, electrons. An electron gun, 2 slits, a detector. What do you see? Stripes, just like water waves. Now things get strange. The 2-slit experiment. Pay attention. This is the most important experiment in the world. Everything strange about quantum mechanics is right here. Turn down the electron gun. Make it fire very slowly, 1 electron at a time. You hear clicks from the detector. Click, click, click. Every click sounds exactly the same. Same loudness, same everything. No half clicks, no quarter clicks. Either 1 complete electron arrives or nothing arrives. Electrons don't come in pieces. They arrive whole, in lumps, indivisible lumps. So here's the natural question. Which slit did this electron go through? Perfectly reasonable question, right? The electron is a thing, a particle, a chunk of matter. It doesn't split in half. It must go through 1 slit or the other. Let's call this proposition A. Each electron goes through either slit 1 or slit 2. Sounds obvious. Must be true. But now watch what happens.
Have you ever felt like
Let the experiment run.
Is stranger
1
than
electron
fiction?
at a time.
Well,
Click,
get
click,
ready,
click.
because we're
Slowly
diving
building
into
up a
the
pattern
world
on the
of
detector
quantum
screen.
physics,
And the
where
pattern
the
you get,
rules of our everyday
stripes.
world just
The
don't
same
apply.
interference pattern you got
It's
with
not
water
as
waves.
scary as it sounds.
Stop right there.
I promise.
Think about what this means.
We are going to explore
If each
one
electron
of the most
goes through only
mind-bending
1
experiments
slit,
ever conceived,
what is it interfering with?
the double-slit
Think carefully.
experiment.
1 electron goes through,
Imagine you have
arrives
a
at the
wall
screen.
with 2 tiny
Then
slits
another
in it.
electron goes through,
On one side,
arrives at the screen.
you have a machine
1
that
at a
shoots
time,
tiny balls,
minutes apart
like
if you
marbles,
want.
towards
Each electron
the wall.
is completely
What do you
alone.
expect to see
There's
on
nothing
the back
else to
wall?
interfere with.
You'd see
Yet somehow
2
you
lines of
still
marks,
get the interference
right where
pattern,
the marbles
the
went through
striped
the
pattern.
slits.
How?
Simple enough.
Let's test proposition
That's
A
how
carefully.
particles behave in
Close
our
slit
classical
2 completely.
world.
fire
Now,
electrons.
let's switch
You get a
from
certain
marbles
distribution.
to waves.
Most electrons
Imagine
land
sending
opposite
water
slit
waves
1,
towards the
fewer
same
at the
wall with
sides,
2 slits.
a single hump.
When the waves
Call
pass
this
through,
pattern
they
1.
don't just form
Now
2
close
lines.
slit 1 instead.
They
Open
interfere
slit
with
2.
each other.
Fire
The
electrons.
peaks of one
You
wave
get pattern
combine
2,
with the peaks
a
of
hump
another to
opposite
create
slit
bigger
2.
waves.
Now
And
open
peaks
both
cancel
slits.
out troughs.
If proposition
This
A is true,
creates a complex
if each
pattern on the
electron
back
really
wall
goes through one
called
slit
an
or the other,
interference pattern,
then the result
with
should just
many
be
lines of
pattern
high
1
and low
plus
intensity.
pattern 2 added together.
So
Some electrons
make
go
2
through slit
lines,
1, make
and
pattern 1.
waves make an interference
Some go through
pattern.
slit 2, make
Got
pattern
it.
2. Add
Here's
them up.
where it gets
That's
weird.
what you should get.
Let's find
That's not
something
what you get.
really
Look at the center
small,
point, equal
like an
distance from both
electron
slits.
at the 2
With
slits.
both slits open,
An electron
many
is a
electrons arrive
particle,
there,
a
a
tiny
bright spot.
speck of matter.
But close
right?
slit 2,
So
fewer
we
electrons
should
at that
expect to
point.
see 2 lines on the back wall,
Close slit 1
just
instead.
like with the marbles.
Again, fewer
But
electrons
that's
at
not
that
what
same
happens.
point. So
Instead,
closing either
we
slit
get that
actually
wavy
increases the
interference
number
pattern
arriving at
with
certain
many
spots
lines.
and
It's
decreases
as if
it at
each
others.
single electron
How can closing
somehow
a slit
went through
that the
both
electron
slits at the
supposedly
same
didn't
time,
go through
like a
change
wave,
where it
and
lands?
interfered with itself?
At some places, you get more
How
than
is
twice
that
as many
possible?
electrons with both slits
Scientists were
open
baffled.
compared to having
They
just
thought,
one open.
Okay,
At other
let's try to
places,
see
you get
which
almost
slit the
none with
electron
both
actually
open,
goes through.
even though you got
So
plenty
they
with
placed
one
a tiny
open.
detector by the
This
slits
is interference,
to observe the electrons.
exactly like waves.
And this
But
is
remember,
the part that
the
will
electrons
blow your
arrive as
mind.
particles,
The
one
moment they
whole
started
lump at a
watching,
time.
the behavior
Here's what makes it so
changed.
puzzling.
With
How
the
does an
detector
electron
on,
going through
the
slit 1
electrons suddenly
know
acted like
whether
proper,
slit 2 is open or
well-behaved
closed?
particles.
The mathematics
They
is
went
simple,
through
though.
one slit
Beautifully
or the other,
simple. You
and the
calculate it
interference
exactly
pattern
like
vanished.
water waves
All
interfering.
that was left
But the
were
physical
2
meaning,
simple lines,
that's where it gets
just like
strange.
the marbles.
Electrons
It's as if
arrive
the
in
very
lumps,
act of
like
observing
particles.
forced the
But
electron
the probability
to choose a
of where they
path,
arrive
to
is
stop
distributed
being a
like the
wave of
intensity of a wave.
possibilities and become a
Now
definite
let's do something that
particle
seems
in a
clever.
definite
You
place.
say, okay, I want to see
This is
what's
the
really
core
happening.
mystery
I
of
want to
quantum
watch
mechanics,
which slit
the
each electron
observer
actually
effect.
goes through.
It tells us that
So
at
you
the
set up a
tiniest
strong light
scales,
source behind the 2
reality
slits.
is fuzzy
When an
and
electron passes through a
probabilistic.
slit, it'll scatter some light.
Particles
You'll
exist
see a little
in
flash.
a state of
That
multiple
flash will tell you this
possibilities at
electron
once,
went through slit
a
1,
superposition,
or this
until
electron went
we
through
measure
slit
them.
2.
The
Perfect
act
plan.
of
Let's do
measurement
it.
collapses all
You run the
those
experiment.
possibilities
Fire
into
electrons
a
one at a
single,
time.
concrete
Watch carefully for
outcome.
light flashes.
It's
And
like
here's
the
exactly what you
universe is
observe.
playing a
Every
cosmic
single
game of
time you hear a
peekaboo
click
with
from the
us.
detector, meaning an
So
electron
what does
arrives,
this all mean?
you also see
It
a
means
flash
the
of light,
universe
either
is
near slit 1
fundamentally
or near
uncertain.
slit 2.
We
Never
can only
both
talk
at the same
about the
time.
probability
Never
of finding
halfway
a
between.
particle somewhere.
Excellent.
Not its
So
exact
proposition A was
location
correct
until
after
we
all.
look.
Each electron
This
really
discovery
does go
completely
through one
changed
slit
our
or the other.
understanding of
We can
reality
actually
and
see
paved
it
the
happening.
way for
We can watch
technologies like
which path it
lasers,
takes.
computers,
Mystery solved
and
then?
medical imaging.
Not quite.
This
Not at
isn't
all,
just
actually.
a quirky little
Look at the
experiment.
detector screen now.
It's a window
Look at the pattern
into
of
the
where
deep,
electrons are landing.
strange,
The striped
and beautiful
interference
nature
pattern
of our
has
universe.
completely
It
disappeared.
shows us that
Instead, you
reality
just get
is
2
far
humps.
more mysterious
Exactly
and
what you'd expect from
interconnected
proposition
than we can
A.
imagine.
Exactly what
So
you'd
next
get if
time
you were
look at the
shooting
world
bullets.
around you,
The
remember
pattern is
that
simply
beneath the
pattern
surface,
1 plus
there's a
pattern
whole
2
quantum
added
realm
together.
dancing to
No
its own
interference,
bizarre
no
rules.
stripes. Gone.
Thanks for joining me
When
on
you
this
watch
journey
which
into
slit
the
the
quantum
electron
world.
goes through, the
If you
interference
enjoyed
pattern
this
vanishes.
and want to explore
When you
more
don't
mysteries
watch,
of science,
it comes back.
make
Your
sure
observation
to like this video
has
and
changed the
subscribe
experimental
to the
result.
channel.
But
See
hold
you
on.
next time.
Maybe the problem is that the light
Partial
is disturbing the electrons. Photons
Partial
are hitting the electrons,
interference.
giving the little kicks,
The correlation
messing up their
is
paths.
exact,
That's why the interference
quantitative.
disappears.
The more
reasonable thought.
information you have about
So let's use
which
dimmer
path,
light, more
the
gentle,
less
less
interference
disturbance.
you see.
You turn
This
down the intensity of the light
observation led
source.
to a
At first
fundamental
nothing changes.
principle,
Same results as before.
uncertainty
You still see
principle.
flashes.
For
Pattern
this
still shows no
particular
interference.
experiment,
But as you
can
make the
state
light
it
dimmer
like this.
and dimmer,
It is
something
impossible
very
to
interesting
design
starts to
any
happen.
apparatus that will determine
Sometimes you hear a
which
click
hole
from the
electron
detector.
passes
Electron
through
arrives.
without destroying
But you
the
don't see
interference
any flash
pattern
of light
in
at
an
all.
essential way.
Why not?
If your
Where did the flash
apparatus
go?
is good enough to
Here's
tell you
why.
which slip,
Light doesn't
the
come as a
interference
continuous
will be
wave.
destroyed.
It comes in lumps,
if
too.
you see
Particles called
interference,
photons.
your apparatus
When you dim the
cannot
light
tell
source,
you which
you're
slit.
not making each
You
photon
cannot
weaker.
have both.
You're just sending out fewer
This is
photons
not a
per second.
technological
The
limitation,
light is getting sparser.
not about
So
needing
sometimes an
better
electron
equipment.
goes through the slits,
It's
and there simply
fundamental to
wasn't a
nature.
photon there at that
Here's
moment
the
to
rule.
scatter off it.
If you
No
can
photon,
determine which
no
slit,
flash, no
no
information
interference.
about which slit.
If there's interference,
Now you can divide your results
you
into
cannot
groups.
determine which
Electrons
slit.
where you saw a flash
You
at
can't
slit
have
1.
both,
These electrons
You
land
might
in
say,
pattern 1.
but it
A
must
hump
really
opposite
go
slit
through
1. No
or the
interference.
other.
Electrons
just
where you saw a
don't know
flash at
which.
slit 2. These
No,
electrons land in
that's
pattern
the
2.
mistake.
A hump opposite
Assume
slit
it
2.
goes through
No
1,
interference.
but we don't
Electrons
know.
where you saw no
You
flash at
predict
all.
2 humps.
These electrons show
Wrong
interference. The striped
Nature
pattern is
doesn't
back.
work that way.
Stop and think about what this
Calculation
means.
is simple.
Really think about it.
For every
The electrons you
possible route
detected,
the electron
the ones
can
that
take,
scattered a photon so you
assign
could
a
see which
complex
slit they
number,
used,
a little
these
clock
behave
face.
like classical particles.
Electron leaves
They
the
go
gun,
through one slit,
goes
you
to
can
the
tell which
screen.
one, and they make a simple
Thousands
pattern.
of possible
No
routes
interference.
through slit 1,
The electrons
through
you
slit
didn't
2,
detect, the
even
ones
to
that didn't happen to
Andromeda
scatter a
and back.
photon, these
Every
show
route
interference.
gets a clock.
They make the striped
Follow
pattern.
the path.
This is not simply
Clock
about
hand
physical
spins.
disturbance. It's about
Calculate
information,
where it stops
about
for
knowledge,
each route.
about whether the
Add
path
up
is
all the
distinguishable in
All
principle.
possible
Try
routes.
using even
The
longer
length of
wavelength
the
light
total
now.
clock
Red
hand
light
gives you
instead
the
of blue.
probability.
Or infrared,
Some clocks point the
or radio
same
waves with
direction,
very long wavelengths.
reinforce.
You try this.
Some point
As the wavelength
opposite.
gets longer and longer,
Cancel.
something remarkable happens.
That's interference.
With very long wavelengths, the light
Does the
doesn't pinpoint
electron
which slit
really
very
explore
precisely
all
anymore.
routes?
Why not?
Really go to
Because when the
Andromeda.
wavelength becomes comparable to the
think so.
distance between the slits,
That's what
the light
nature tells us.
diffracts. It
We
spreads
know
out.
how to
A
calculate.
flash of light could have come
We
from an
get the
electron at
right
either
answer.
slit. You
But
can't
what it
tell for
means,
sure anymore.
Nobody understands
here's the remarkable
way they'd
correlation.
like to.
As soon as you
What's
lose
an
the ability
atom?
to distinguish which
Positive
slit,
nucleus.
as soon as the information
Negative
becomes
electrons
unreliable,
around it.
the interference
Opposite
pattern
charges
starts
attract.
coming back.
Why don't
Perfect
electrons
distinguishability,
fall in?
no interference.
Classically, they
No
should.
distinguishability at all,
Moving
full
electrons should
interference.
radiate,
partial
lose energy,
distinguishability,
fall in,
partial
but they
interference.
don't.
The correlation
Why?
is exact.
The
Quantitative.
uncertainty principle.
The more information you have about
Suppose
which
the
path,
electrons
the
sat
less
on the
interference you
nucleus.
see.
You'd
This
know
observation led to a
exactly
fundamental
where it
principle,
is.
the uncertainty
No
principle.
uncertainty in position.
For this particular experiment, you
But
can
then
state it like this.
momentum uncertainty
It is
must be
impossible to
very
design
large.
any apparatus that will
Large
determine which
momentum
hole the
means
electron
large
passes through
kinetic energy
without
enough
destroying
to
the
break
interference
away.
pattern in an
So
essential
the
way.
electron compromises.
If your apparatus is good
stays
enough to
some
tell you which
distance
slit,
away.
the interference
Some
will be
position
destroyed.
uncertainty,
If you see
some momentum
interference,
uncertainty,
your apparatus cannot
some
tell you which
kinetic
slit.
energy.
You cannot have both.
Work this out.
This is
You
not
get
a technological
atomic radius
limitation,
of about half
not
an
about needing
angstrom,
better equipment.
110
It's fundamental to
billionth
nature.
of a meter.
Here's the rule.
That's right.
If you can determine
And
which
the
slit,
energy to pull
no
an
interference.
electron off hydrogen
if there's
about
interference,
14
you
electron
cannot
volts,
determine which slit.
matches
You can't have
experiment.
both.
The
You might say,
reason
but
you
it
don't
must
fall
really go
the
through one or the
floor
other.
is
We just don't know which.
quantum-mechanical.
No.
To squash
That's the
atoms
mistake.
closer,
Assume it goes
confine
through one, but we
electrons
don't
to
know.
smaller
You
space
predict two humps.
by
Wrong
uncertainty
answer.
principle,
Nature doesn't work that
momentum
way.
would be
The
higher.
calculation is simple.
Higher
For every
energy
possible
that
route
resists
the electron can
compression.
take, assign
Let me
a
show
complex
you
number.
why uncertainty
A little clock
is
face.
built into nature.
Electron leaves the gun,
Think
goes to the
about a
screen.
wave train.
Thousands of possible routes.
Finite
Through
length.
slit 1, through
Trying
slit
to
2,
count the
even to
waves.
Andromeda and back.
How many
Every
peaks?
route gets a clock.
At the edges,
Follow the path.
the wave
Clock hand
dies away.
spins. Calculate
You're
where it stops for
uncertain
each
by
route.
about one
Add up all
wavelength.
the clocks,
In
all
quantum
possible
mechanics,
routes. The length
wavelength
of the total clock
determines
hand
momentum.
gives you the probability.
So uncertainty
Some
in
clocks point the
wavelength
same
means
direction,
uncertainty
reinforce.
in momentum.
Some point opposite,
And wave
cancel.
packet length.
That's interference.
That's where the particle
Does the electron
might
really
be.
explore all routes?
Position
Really go to
uncertainty.
Andromeda?
Put it
I
together.
think so. That's what
Position
nature tells us.
uncertainty times
We know how to
momentum
calculate. We
uncertainty
get the
is
right
at least
answer.
a fixed
But what
number.
it means,
That's the
nobody understands
uncertainty
the way they'd
principle
like to.
from wave
What's an
nature
atom?
of matter.
positive
You
nucleus.
cannot have a
Negative
particle
electrons around it.
perfectly localized
Opposite charges
with
attract.
perfectly definite
Why don't
wavelength.
electrons fall in? Classically,
Not
they should.
because of measurement.
Moving electrons should
because of
radiate,
waves.
lose energy, fall in,
Short-wave
but they
packet,
don't. Why?
Well localized. Must
uncertainty
contain
principle.
many wavelengths.
Suppose the electron
many
sat
momentum,
on the nucleus.
Long wave
You'd know
packet,
exactly where it
definite
is.
wavelength,
No uncertainty in
spread
position.
out in space.
But then momentum uncertainty must be very
localization.
large.
You
Large
cannot
momentum
have
means
both.
large kinetic energy,
An
enough
atom
to break
can
away.
only have certain
So the electron
definite
compromises,
energies,
stays
not
some
any
distance
energy,
away, some
specific
position
values
uncertainty,
only.
some momentum uncertainty, some kinetic
Think of
energy.
the electron
Work this
wave
out, you get atomic
confined
radius
in
of
the
about
atom,
half an angstrom,
like
1/10
sound
billionth
in
of a
an
meter.
organ
That's
pipe.
right.
Confined
And the energy to
waves
pull an
have
electron
definite
off hydrogen,
frequencies,
about 14 electron
resonances.
volts.
Same
Matches
for
experiment.
electrons.
The reason you don't
Confined to
fall
the
through the
atom,
floor is
The
quantum
wave
mechanical.
can only have
To squash
certain
atoms closer,
frequencies,
you'd confine
certain
electrons to
energies.
smaller space.
Lowest
By uncertainty
energy,
principle, momentum
ground
would be
state.
higher. Higher energy,
Higher
that
energies,
resists compression.
excited
Let me show you
states.
why uncertainty
An
is
atom
built
in
into
an
nature.
excited state eventually drops
Think about a
to
wave
lower
train.
state.
Finite
Radiates
length.
light.
Try to count the waves,
The
how many
light
peaks.
frequency
At the edges, the wave
determined
dies
by
away.
energy difference.
You're uncertain by about one
This
wavelength.
explains
In quantum
atomic
mechanics, wavelength
spectra.
determines momentum.
Why
So
atoms
uncertainty in
emit
wavelength means
specific
uncertainty in momentum.
frequencies only.
And wave packet length,
two
that's where the particle
electrons,
might be.
Scatter them
Position
off each
uncertainty,
other.
put it together.
Put a detector
Position
at
uncertainty
some
times
angle.
momentum uncertainty
You
is at least a
detect
fixed
an
number.
electron.
That's the uncertainty principle.
electron?
From wave nature of matter.
Left
You
or
cannot
right?
have a particle perfectly
Can't tell.
localized with perfectly definite
Electrons
wavelength.
are
Not
identical.
because of measurement, because of
you
waves.
can't tell.
Short wave
Something
packet,
strange
well
happens.
localized, must contain
Two
many
ways to get
wavelengths,
an electron
many
in your
momentum,
detector.
long wave packet, definite
Left
wavelength,
electrons scattered
spread out in
toward
space,
you, or
poor
right
localization.
electrons
You cannot have
scattered
both.
toward you.
An atom can only have
Cannot
certain definite energy,
distinguish these.
not any energy,
So
specific values only.
amplitudes interfere just
Why?
like two-slit
Think of the
experiment.
electron wave
For
confined in the atom.
electrons, when you
Like sound in an
exchange
organ
which
pipe.
goes where interfering
Confined waves
amplitude
have
has
definite
minus
frequencies,
sign for
resonances.
some particles.
Same for
Alpha
electrons.
particles plus
Confined to
sign
the atom, the wave can only have
Why?
certain frequencies,
has to
certain
do
energies.
with spin.
Lowest energy,
Electrons
ground
have
state.
spin 1/2.
Higher energies, excited
Alpha
state.
particles spin
An atom in an
0.
excited state eventually
Half
drops to a
integer
lower
spin
state.
particles
Radiates light.
interfere with minus
The light
sign
frequency
when exchanged.
determined by energy difference.
Integer spin particles
This explains atomic
interfere
spectra,
with plus sign.
why atoms emit specific
Deep
frequencies
fact about
only.
nature.
Take two
Enormous
electrons,
consequences.
scatter them off each other.
Why
Put a
matter
detector
has
at some
structure.
angle. You detect
Why
an
you
electron.
can't put all
Which electron,
electrons
left
in
or right?
Same place.
Can't tell.
Why periodic
Electrons are
table
identical.
works.
Because you
Things
can't
on
tell,
small scale
something
behave
strange
nothing like things on
two
large
ways
scale.
to get an electron in your detector.
Not like waves.
Left electron scattered
Not
toward
like
you,
particles.
or right electron
like
scattered toward
something
you.
else.
Cannot distinguish
No
these.
everyday experience.
So amplitudes interfere.
We have a precise
just like
way
two-slit
to
experiment.
calculate.
For electrons,
Mathematics
when
is
you
simple.
exchange which goes
The
where,
problem is
interfering amplitude
interpretation.
has minus
What
sign.
does it mean?
For some particles,
What's
alpha
really
particles,
happening?
plus sign.
Nobody
Why?
agrees on that.
Has to do with spin.
But we know when you
Electrons
cannot
have spin
distinguish
1/2.
alternative roots,
Alpha particles
add
spin
amplitudes,
0.
then square.
Half integer
When you
spin
can
particles
distinguish,
interfere with
even if
minus
you don't
sign when
look,
exchanged.
Add
Integer
probabilities
spin particles
directly.
interfere with plus
That
sign.
rule explains
Deep
everything
fact
we
about
observe.
nature. Enormous
Observation
consequences.
matters.
Why matter
Whether
has
you
structure.
can in principle
Why you
determine
can't put
which
all
root
electrons in
changes
same
the
place.
result, not
Why
because
periodic
you
table
disturb
works.
things.
Things
because
on small scale behave
distinguishability
nothing like
determines
things on large
interference.
scale. Not like waves,
Uncertainty
not like
principle is
particles,
fundamental.
like something else.
Position
No
and
everyday
momentum
experience.
cannot both have definite
We have a precise
values.
way to calculate.
Not that we
Mathematics
don't know them.
is simple.
They don't
The problem
have them.
is interpretation.
Quantum probability
What does it
is
mean?
different from
What's
classical.
really happening?
Classical
Nobody agrees on that.
probability reflects
But we know
ignorance.
when you cannot
Quantum
distinguish
probability
alternative
is
roots,
built into
add
nature.
amplitudes then square.
Strange.
When you can distinguish,
Yes.
even if you don't look,
Counterintuitive.
add probabilities directly.
Absolutely.
That
But
rule
it's how
explains
nature
everything we
works.
observe.
And every
Observation
prediction
matters.
we can test
Whether you
matches
can, in
experiment
principle,
to incredible
determine which root
precision.
changes the result.
We don't understand
Not because you
it the way
disturb
we'd
things,
like to,
Because
but we
distinguishability
understand how to
determines
use it,
interference.
and it works.
Uncertainty principle is
physics.
fundamental.